Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Konrad.
Welcome back to another episode of the Reliability Matters podcast. I'm so glad you're with me today. Even though you're seeing this at the earliest at the end of February 2022, this is the first recording of the new year of 2022. We're doing this on January 5th. And I do feel compelled, therefore, to say Happy New Year. I wish you all a very happy and safe, healthy, prosperous New Year. And for those of you who are part of our podcast family, welcome back. This may seem like a very untimely topic in the midst of a supply chain crisis, but we're going to talk about storage systems for electronic components, even though we're in the midst of finding things to store. But sooner or later, this too shall pass, and we will come back to the question of, how do we store our parts? It's often said that we don't have time to work on the important because we're busy working on the urgent. My guest today is Mike Adamson, product manager for Inovaxe Corporation, a provider of material handling systems and services for the electronic assembly industry. In today's hyper-competitive electronic assembly industry, very hyper-competitive, efficiency and optimization are key to maintaining competitiveness. And we're going to talk about how we can increase our efficiencies and therefore become more competitive through storage systems and smart choices when it comes to storage systems. But a little bit of an intro on Mike and a little bit of info on Mike. Mike received his bachelor's of science in physics from the University of Wisconsin LaCrosse, as well as a bachelor's of science in electrical engineering from the University of Minnesota Twin Cities. In addition, as if that wasn't enough, Mike also earned an MBA in marketing from Lynn University. Mike, welcome to the show. I appreciate you being here.
Hey, thanks for having me. I'm really excited to be here.
Well, of course. I watched a presentation that you gave at SMT AI. It was one of the, I'm not sure if you were there live or virtual or both, but I saw the virtual one. And it was quite interesting. It involves a technology, a method, a technique that probably goes back to the Stone Ages, way before electronics and were discovered and implemented on this planet. And it involves material handling, something that, frankly, I'm a manufacturer. I run a factory. I never really gave that a second thought. I just bought storage shelves and threw things on shelves, right? And then I thought automation and efficiency was better markings on the shelf, right? So let's talk about material handling. But first, for the sake of my audience and myself, give me what do you mean by material handling? Just kind of put all the things, when we talk material handling, just scoop up everything, put them in one bucket and tell me what they are.
Yeah, at its simplest, it really is moving material, right? It's handling it, it's moving it from one location to another. Usually in our type of context, we're thinking of components within a building moving from a stockroom to the production line, something like that. Could be from a transportation vehicle to inside of the building as well. Once you start moving between buildings or between locations, then you're thinking more logistics and things like that. So at its core, it's moving around your material components in your factory, getting things where they need to go.
Now, you did kind of a then and now. I'm going to bring that up on the screen in your presentation. Tell me what I'm seeing here. We're looking at the way factories used to be laid out back in the day versus today, right? Mm-hmm. Tell me what some of those differences are.
Yeah, so in electronics alone, obviously there's been huge changes and advancements throughout the years. Looking back, I think this was a picture, I think it was from the 60s at a Samsung facility, if I remember correctly. But, you look at that picture and you see a lot of manual processes, people manually placing things in this box build or electronics assembly process. Versus today, we've had huge advancements in automating the types of things we see people doing in these photos. So the placement of components, the soldering of components, the inspection of components, the insertion of pieces together in a final assembly process, right? So all of these huge advancements have been made throughout all of these really important manufacturing processes that we're, dealing with almost to the point where manufacturing is scarcely recognizable in the electronics realm today from what it was, 30, 40 years ago, right?
Right. So much has changed in manufacturing, obviously, with automation, automated pick and place machines and reflow processes and AOI and all those various steps. But up until more recently, at least from my perspective, I hadn't noticed it before, but up until more recently, I hadn't seen the same level of advancement in storage technology. It's always been kind of rack and bin kind of storage technology. It's been said by one of my guests on the show a while back that one of the keys to competitiveness is automation. And his point was that any, say, for example, North American contract manufacturer can compete with any worldwide contract manufacturer through automation,
Right.
because if you take the labor equation out of it, automation costs pretty much the same no matter where you are in the world, and implementation of that costs the same no matter where you are in the world. So we can have less reliance on labor and more reliance on automation. How can revisiting storage systems and methodologies and mindsets aid in that quest to become more efficient and therefore more competitive?
Yeah, so I'd say, broadly speaking, there's really two broad areas where you'd see some of those improvements and efficiencies, at least right away, or that would be really obvious. So one is a physical aspect, the space that you're storing your components in, right? If you're going from 1,000 square foot stockroom to 100 square foot stockroom, right? There's huge efficiencies can be gained from something like that. In terms of the travel time, in terms of where your material is located as well. So new and different material handling systems kind of allow you to look at where your material can be placed. Whereas typically we're kind of looking like, there's my stockroom over in the back, and that's where everything is stored, and that's the way it is. So that's one aspect of it. And then, of course, the other aspect for the material handling side would be a data flow aspect, linking different systems together, eliminating human decisions that introduce errors, eliminating manual data entry, things like that on the data flow side that are going to really bring a lot of efficiencies as well.
Excellent. Let's go kind of in a time machine and our Wayback Machine, so to speak, and go back in time. Let's talk about rack and bin storage. I think you can go back about 50 years, at least in this industry, probably more, and see the exact same rack and bins as we do today. What are the advantages of the tried and true rack and bin technology? I mean, clearly it's worked for a lot of years. It has survived automation, meaning it hasn't really had the need, well, maybe not, that's the wrong way to put it. It just hasn't ended up being as automated quickly as other aspects, as I said earlier. There are always advantages in sticking with tried and true. There's always risks associated, at least perceived risks associated with going out on a limb and trying something that is, newer and a little bit more revolutionary. What are the advantages of rack and bin storage, and what are some of the disadvantages of traditional rack and bin storage?
First, in terms of the advantages, I mean, it's just so simple to understand and easy to implement, and we really see it everywhere. It's kind of the default way that we store things, right? So what we talk about typically with rack and bin is you have a storage rack with some bins on it, and you put your parts in the bin. Usually it's like, this bin is for part number A, this bin is for part number B, and so on. It's the same thing when you go to the grocery store, right? There's a cereal aisle, there's a location for the Frosted Flakes, and you kind of have an intuitive sense of how to get there. There's a produce section, and there's a spot for the apples, and so on. There's a silverware drawer upstairs with my forks and knives, right? So this is just the way that we try to store things when we're looking to put material away. So in addition to that, it's really flexible and easy to accommodate. So if you have a really increased need of storage capacity, it's very easy to bring in some more, metro racks. It's very easy to tear them down if suddenly you need half the capacity. So it's just very easy to get into. And of course, it's really inexpensive, relatively inexpensive anyway, on the upfront, investment costs out of pocket. But of course, some of the disadvantages really are going to come back to bite you later, right? So you'll have potentially a lot of wasted storage space. Some of the photos that we see, some of the factories that we visit, you'll typically see a bin with like 1 or 2 reels. So yeah, this is one of our favorite pictures. Some of these bins here are completely empty. When we look at this, we say anywhere that is air is wasted space, right? That is space that you are not taking advantage of. We're holding these locations open, just waiting for something to come in, right? And on the flip side, you have locations that are completely overflowing, right? There's space enough for 20 reels in this bin, but you have 30 in stock today. Well, where are those extra 10 going to go? And it just compounds all of these potential problems.
That, by the way, would be a good problem to have today.
Right,
Too much inventory, right?
You're telling me.
We pine for those days, yes.
Oh, man. So, the other thing is a lot of potential for human errors. Typically, we're pulling off of a pick sheet in this type of environment. We're going to a specific location that has a dozen reels in it, and I got to get the right one. I got to get the right quantity, perhaps needs to be the right manufacturer, the right lot code, any number of different things that would constitute the correct reel for this pick, right? So many different areas for them to make a mistake. And then most commonly, that reel, when it's being removed or added, has to be transacted in some way. MRP system needs to know about it. So whether that's scanned or manually entered, there's other steps in these processes. So it's not only some inefficiencies with the rack and bin storage itself, but then the processes you have to put in place in order to make the system, workable in a modern environment can really slow things down over time.
You talk in your presentation about rack and bin storage being more of a mindset, not just a technology, but a mindset. What comprises that mindset? What comprises that mindset? And does that same mindset that tells people to just stick with tried and true old, horizontal shelves and stack vertically, does that mindset show itself in other parts of a factory as you experience it? Does that make sense?
Yeah, absolutely. So in terms of the mindset, rack and bin is like a really useful shorthand for it, right? But it's not the rack itself and the bin itself that it's important. It's how you're storing the parts. So kind of dedicating the space to a particular part number. Whether you have 10 reels in stock or 0, you still have the space dedicated. So out there in the wild, we've seen people storing reels in plastic bags on coat hangers. We've seen them, put on rods, in file cabinets, right? But fundamentally, it's all the same type of system. So that's kind of what I'm getting at with that mindset. And what's difficult about overcoming some of that inertia is that because it's the default way that humans just want to put things together, right? It's hard for us to step outside of that on our own. So one analogy I kind of make is if we think about the way that a computer stores something in a database, it's a very efficient line-by-line representation of all of this data, and it's very fast and simple for a computer to get to that. If we needed to sort through 10,000 lines in a database, it would take us ages, right? But when we set things up in this rack and bin type of way, we have an intuitive understanding of where things are located in this default methodology. So without some new technologies, whether that's software, hardware, equipment, it's going to be really difficult to step outside of these bounds on your own. You
compared computer technology as an analogy to further that analogy, defragmenting a hard drive is much like taking all that empty space out of your storage and putting everything closer together, so you have to walk less. I guess that analogy can just go on and on forever.
Absolutely. Actually, really quick, the storage space, it is such an overlooked component here, because we're so used to thinking of, again, this is generalizing, but we have our stockroom in the back and it's kind of a setup space. And yeah, it would be nice if our stockroom was a little bit smaller, but at the end of the day, if it's 1,000 square feet or 800 square feet, it's not a huge difference. We literally have seen customers, manufacturers out there, reduce their storage space by 90%, right? Think about the difference in 1,000 square feet versus 100 square feet, where you can put your material, right? So I just wanted to stop on that one point with the storage space, because it feels like a luxury to a lot of people, right? But when you can store your material in a fraction of the space, you can put it right on the production line, right where it needs to be, right? Eliminating a stockroom entirely for the right operation. So
one of my guests from last year, Patrick Stimpert from Matrix Group, they're a contract manufacturer, and he was the one that talked about how any company can be competitive to any other company in the world through efficiencies and automation, things like that. And I've never seen or talked to anyone who is as focused on efficiency. He gives an example. If someone's right-handed, he tells them, don't keep your pencil on the left side of your desk, because that takes extra time. So if someone is that anal about efficiency, you can imagine. And they actually designed their assembly line in an 8 pattern, kind of a horizontal 8. And they have 2 loading doors, one for stuff coming in, one for stuff going out. And they made sure that each end of that 8 was logistically thought of in terms of the loading doors. And they put part storage. I'm not sure. I don't remember if it was automated or more traditional, but they put part storage throughout the factory floor so that everything was very close to the place where it would be needed. And apparently that and many other types of logical layout and automation techniques really allowed them to be hyper competitive with pretty much any factory in the world, which, to your point. So we were talking about rack and bin, and like you said, rack and bin is a placeholder for a lot of things. It doesn't necessarily have to be rack and bin, but it's really more of a mindset, as you said. What are the alternatives to traditional storage? What are some of our options now that we've talked about some of the inefficiencies of the traditional method of storing components and other things? What are our alternatives?
Yeah, so kind of going back in time to what would have been some of the first solutions here, and they're still around today and can be very useful, would be like carousel type systems. People will be typically pretty familiar with a vertical carousel, right? That kind of takes a shelf and rotates it in the air about an axis. So this is kind of taking the different rows of the shelf and bringing it to you, rather than you walking around your stockroom to each different row.
Is this an example of what we're seeing on the screen? This is more
exactly.
of a vertical storage.
Exactly right.
That's what we're talking about. Yeah.
Yep. There's also horizontal carousels where they'll traverse the material around on the floor. But either way, you're kind of staying in place, and the carousel system is bringing a shelf or a rack to you, more or less. Moving forward, and these have become, commonly well known and well used, especially in the past few years. Now we have SMT storage towers, things that were really designed for electronics components, right? And storing the reels individually. And then we've also seen the introduction of products like smart storage systems, what I might call them, where still a semi-manual process where people are handling reels, but there's a lot of software and potentially hardware automation involved as well. And again, like you said about some of the things earlier, trade-offs, benefits, advantages to all of the above.
Okay, let's dig into that. That's perfect timing. Thanks for the segue. What would the downsides be to, let's just say, a carousel-based storage system or other automated or semi-automated storage systems? Everything has pros and cons. So let's dive into the cold end of the pool. What are the cons potentially of that?
One of the main cons, I'd say, of the carousel type systems, at the end of the day, it's usually still just a rack and bin type of system. So there's still a shelf with some bins in it, and you're putting your material there. You obviously reduce a lot of travel time because you don't have to walk around the stock room, but fundamentally still rack and bin. There's always index time between each different row or the different racks as they're bringing around to the pickers. So they're generally not going to be as fast or efficient as you can get. But vertical carousels especially can take really good advantage of vertical space. You're not going to be able to get more dense storage than vertical carousels if you have 80 feet overhead to go. So that's really where they're going to shine.
Yeah, when we buy a building, we base it on square foot, cost per square foot. Fortunately, it's not cubic foot, so we don't have to. We're not paying for, between the floor and the roof is all included, right? So, and that is space that's quote unquote free.
Exactly.
And let's talk about, in your presentation, you talked about a couple of different technologies. You talked about carousel-based storage and robotic-type storage. What's the differences between those two?
Yeah, the robotic-type storage is going to be more the SMT-specific storage, so where an individual package is being handled by the storage system. So just to stick with the SMT reel, one reel goes in and it goes into a particular slot inside of the machine. You can feed it a pick list, look for an individual reel, something like that, and the machine is going to deliver you one or more reels depending on the capabilities.
Kind of a high-tech jukebox, kind of, right? It just goes in and grabs it, and instead of playing it, it hands it to the operator.
Exactly right. Exactly right. Yep.
Okay.
A lot of them will have options for moisture-sensitive storage inside, so you can have add-ons to keep the humidity below 5%. That can be a big benefit with the SMT storage towers as well.
Sure, that's a good value add right there.
Yeah, big time. And when they're delivering a reel to you, you're eliminating some of those human errors. There's good opportunity for integration with other systems, so kind of making the data flow more efficient.
I was going to ask you that. So I was going to ask you that a little bit later, but since you brought that up, how do automated systems work with Industry 4.0, for example? Are there already protocols for Industry 4.0 for automation? Have we reached that level yet, or is that still down the list?
More or less, I'd say we've reached the critical components anyway, in terms of kind of being able to identify where reels are. So typically what you're talking about with integration and material handling would be anytime a reel goes into an area, it's added to the stock room, it's put into a storage tower, it's added into a smart storage system. That's notifying an MRP system, an MES system, something like that. When reels are removed, we're also notifying that external system as well, right? So we can keep everybody in sync. These types of data points are there in like the CFX standard, for example, but they're very common things that would be integrated between, especially with an MES type of system. And then, of course, on the flip side, those external systems can send down requests for material, a pick list in whatever form that might be.
So is it reasonable to think that if a pick and place machine senses its reel is getting low, it's at the last 20% of the reel, that it would send a message to the storage tower or to the robotic system to get this reel ready, or queue it up, or notify a person to get that reel? Is it that automated yet?
Yeah, absolutely. That's the ideal that kind of everybody wants to reach. Inovaxe, for example, we have customers who are absolutely doing that today. Not everybody can get there with the equipment or the software that the existing SMT equipment might have, but yeah, that type of thing is not only capable, but it's out there in the world right now.
And you use the word smart storage systems. Is that a catch-all for, pretty much anything other than a shelf and or a plastic bin?
Yeah. So smart storage system is going to be something where generally there's not going to be any types of robotics involved, right? So there's still an operator who's placing a package away or removing it physically with their hands. But there's going to be a lot of software in the smart storage system that's going to handle where these reels are located, going to be able to, generally there's an LED that will light up the individual reel, rather than just identifying kind of a location where many reels may be. It is a catch-all phrase because there's a big spectrum in terms of how they work, right? So some systems, a lot of Inovaxe systems, we have sensors in all of our equipment. So you scan a reel, you place it into a location, it's automatically detected where you place that reel, and all of that data transfer we were talking about can take place as well. Other systems, you would scan the reel, scan the barcode at the location where you're putting the reel away. Sometimes there might be a button. Obviously, the sensor gives you a lot of benefits because you have positive recognition when something is placed and positive recognition when something is removed. So
when in my factory, the person who handles our purchasing is also our stock organizer. He's the person who knows where parts should be, how to document where the parts are, how to label the bins appropriately. He's the smart one, not the bins. But if we were, or any of your customers, decide they want to automate the storage process and make it smarter, so to speak, is that a different level of personnel that's required? Do they now need someone more like a machine operator, like maybe someone who runs an SMT line? How seamless of an integration are these types of machines, and how much more skill level is required, not so much to implement, but to run, to facilitate these new technologies?
Yeah, it's a great question. So what we really want to be looking for is to not introduce new skills into the process, kind of like you said, right? So for somebody who is used to going around a stockroom, finding the right location where a part might be stored, something like my kind of smart storage system is going to be even simpler than that. They're going to go around and look for a light that's lit and pull that exact reel. So that's definitely what you want to be looking for, is making sure you're bringing something in that's not going to add all these new skills, that's going to simplify things for you and for everybody involved, rather than add more complications.
Excellent. So switching topics a little bit, the word inertia is described as a property of matter by which it continues in its existing state of rest or uniform motion in a straight line. This is all common to you as a physics degree holder, unless that state is changed by an external force. I believe this applies also to manufacturing methods. You discussed in your presentation the need to change one's perspective on material handling. Would that be considered the external force required to make a change in material handling? So, in other words, what are the external forces that change the inertia of, once things are in motion, they just want to stay in motion. Once we do things a certain way, we just want to keep doing things that same certain way. What are the forces that cause people to call companies like Inovaxe or others to talk about changes to something that have historically served them pretty well?
It's a wide array. We've talked to a lot of manufacturers who are looking for a solution, unfortunately, because they've run into a huge problem recently. They placed the wrong component on 900 boards, something like that, or they lost a key amount of material, which obviously now in the supply chain shortage is even a bigger deal. So something like that is super common. Some people just they're tired of all the headaches they have day in, day out, and they know that something's got to be better out there. So, but it's usually a mix. Everybody's got all of the same problems too. That's one thing I always like to point out when I'm talking to people. Everybody thinks that their material handling problems are unique, and
right?
yeah, and of course everybody is unique in some sense, but everybody's looking for material. It's misplaced. They said they ordered it, they said they received it, but you can't find it. I mean, this is the stuff that everyone deals with.
Yeah, we've been there. And we're a small factory. We've been there. I can only imagine what it's like in a larger factory with more than one person responsible for receiving or ordering or stocking and things like that. So you stated in your presentation that material handling is taking a back seat to other processes. Is material handling frequently the poor stepchild of within a manufacturing process? And if so, what's the reason? What keeps trumping the decision to address efficiencies in material handling?
Yeah, and in a lot of ways, it's almost an invisible problem until it causes a bigger problem, right? Until you need that reel in the machine right now and you can't find it. And a lot of the focus has been on some of the really sexy manufacturing processes, going from manual placement of components on a PCB to tens of thousands of components per hour placed by an automated machine. So the amazing advancements in inspection, the ovens alone, these are all really, like I said, sexy technologies that we like to look at. And it's hard to look at a stockroom full of reels and think that, there's a lot that I can do here. So that's been kind of part of what we're really trying to do, is bring some of this awareness out there that better things are not only possible, but they're out there today. And, you can solve a lot of your problems, even just by making some small changes in your existing processes, even without making a huge investment in something else. But changing that perspective, like you said, thinking about things in a slightly different way can really bring some big returns.
So in our factory, I think it's safe to say our factory floor is about 20 to 30% dedicated for storage, one form or another. You alluded to this earlier, but I want to address it more specifically. If we were to change our mindset and look at storage more strategically in an effort to be more efficient, what, in terms of percentages, how much of our floor space dedicated to storage, based on your experience, could we expect to save? Are we looking at a 20% reduction in floor space? I think you said 90 earlier, which is amazing. If I heard that right. So on a typical, I know no one's typical, but if you could make a typical type of customer, what percentage of floor space can one expect to save? Going from completely manual to, whatever, carte blanche, whatever you recommend.
Yeah, I think something like 60 to 70% in some cases is pretty easy with the right type of investment. Getting up to, like I mentioned before, the 90%, that's a real world example, but it was one that had particularly bad wasted space, right? So right. There's always a difference for what you're starting with. But for a lot of people, 50, 60, 70% is really achievable, and not necessarily with a huge upfront investment.
And talk about investments. Let's talk about the ROI on a typical ROI. Again, everybody's different, but if you were to come up with a kind of a general standard, what type of ROI can one expect, both in savings and in payback time?
Right. I want to see like 6 to 12 months ROI. That's what I'm really shooting for a lot of our customers. Again, nobody's typical, and operations are going to be different. With different types of systems, that might be pushed out to 12 to 24 months. For a very large installation, that could be a little bit longer. But I really want to see 6 to 12 months ROI with my customers.
That's
some of the
very
things
fast.
here
For capital investment, that's very fast.
Absolutely. And we're able to give that because, again, we want to look at the way we're storing our material differently. So we can bring ROI not just in the time savings, which alone, we usually see 5 to 10 minutes it takes someone to find a particular part in a normal rack and bin setup. Sometimes less, usually not more, but 5 minutes. And you bring that down to 5 seconds when the reel is lit up in front of you. That's a huge savings right there alone if you don't do anything different. But some people can use their floor space savings as an ROI as well, right? I pay X dollars per square foot, and now my material, I'm not storing it. It's reduced by 50%, right? We have customers who we help with their ROI on accounting terms because we put our material right next to the production line and it doesn't become WIP until the moment it gets loaded into an SMT feeder, right? So there is big potential accounting ROI on that side. Sure, so this is kind of some of the things
you get an accountant with a sharp pencil and knowing when to convert to WIP. Yeah, right? That automatically saves. Sure.
Yep. And so these are some of the different things we're looking at, and it's kind of what we're talking about with changing the mindset of material handling or changing your perspective for how you're looking at it. We're really looking at it as the lifeblood of your manufacturing operation. Doesn't matter what your processes are, doesn't matter what your SMT equipment is, if you don't have the material there on time, you're not producing, right? Mm-hmm. So starting from that perspective of, in some ways, material is the most important thing I have in my factory. In some ways, all of us are trying to get material in the door and finished goods out the door in one way or another as well. So looking at it like that can really help us here.
So I'm completely new to this. I don't have to set that up as a hypothetical because it's actually true. I don't know much about automated storage systems beyond the traditional rack and bin. If I decided I was going to do some research and really start getting some quotes and getting some ideas and talking to experts like yourself, how would I go about vetting my supplier? What should I be looking for? And I'll throw this in there as well. There are like pick and place companies that are now not building, but selling storage systems, through some private label arrangements and things like that. Am I better off sticking with my pick and place supplier for that example, to provide that equipment? Am I better off going to the actual source who makes the equipment, maybe for other people and directly? And how do I determine who should I buy from? What are you? You're in this business, and obviously you're in this business, and you would be partisan to your company. I totally understand that, but for someone who's new, you might say, "Oh, our equipment has X, Y, Z," and they're going to look at you and go, "Is that good? I don't know." So how would you suggest a potential customer would just kind of start vetting out everybody, and how should they start the process?
Yeah, I think something that's pretty common, most manufacturers will have the different sales reps and distributors that they work with and talk to, right? So that's a very simple first step, reaching out to your reps, see who they represent, what do they have in their product lines that they can offer you right away, right? And that can be a real simple way to get started down that road. In terms of, looking at the different companies or places you could purchase from, the private label thing, my honest first reaction is might as well buy from the pick and place vendor, right? Then it's under their label, they take care of it for you. One less vendor to worry about in some sense, right? So, I would probably suggest going that route to simplify. In terms of what, some of the different solutions are going to offer you in the smart storage space, where Inovaxe sells stuff, I think that the software is one of the key components. Not only what the software can do just out of the box, but what are the integration capabilities? Are there built-in, like out-of-the-box integrations with different systems, MES, pick and place, and so on? And is it easy to use, as we talked about before, right? Are you introducing a whole new skill set? Now somebody has to learn how to use an Android phone when they're an iPhone person or something like that, right? These can all be little factors that can kind of push you one way or the other. And then, of course, testimonials are great, right? Everyone loves to see testimonials. We love getting our customers in contact with, potential other manufacturers out there, to share all of their experiences, good and bad, whatever it may be. Because that's one of the best ways that we learn about new things is from each other. So that's another big thing I'd recommend is any contacts you have other manufacturers, see what they're doing, see what they've heard of as well, and let information flow that way.
When I, back in the day when I was a little bit more involved with day-to-day at my company, I was chief cook and bottle washer at one point, right? I would, if I was going to buy a piece of equipment, I would reach out to the manufacturer, ask for references, as you suggested. But I didn't want to talk to customers who have never had a problem. Frankly, I'm never impressed with that because I don't know if that's an anomaly, right? They might have 2,000 customers and they gave me one that's never had a problem. A broken clock is right twice a day, right? So I'm not interested in that. I'm interested in talking to someone who did experience a problem and what the manufacturer did about it, right? How responsive were they? Because things will break. I mean, it happens. Nothing will last 100 years without breaking. At some point it's going to break either on the first day or on the 1,000th day. And the response to that problem is really what I'm more interested in. And obviously I'm interested in reliability, but I'm also interested in plan B. So I totally agree with getting references with real people that have experienced, both sides of the coin, and I might deal with something exceptionally reliable, but maybe they have a completely unreliable service record, and everything's good until it's not. So I want everything is good until it's not, and then it's good again. I want that's the point of measurement that I'm looking for. So my last planned question, anyway, I'm famous for asking many last questions, but my last planned question is, based on your experience and where you've been and your history, what does the future hold for storage technology? Are we at the beginning of a radical change? Are we kind of through the change and now we're just waiting for people to implement it? Where do you think we are on it?
I definitely think we're either at or just before some radical changes are going to be taking place. I mean, in some ways, we have had some radical changes. Some of the smart storage systems out there are a huge departure from the way that things have been done. But I'm thinking more not only the technology, the hardware itself, the equipment, but things that will be capable on the software side. With this types of space savings, we're going to see some incredible new layouts of factories. You already brought up that figure 8 type of layout for the factory. I think that we are going to, again, I think in 30, 40 years, it's going to be scarcely recognizable is probably a safe bet.
And I guess, the term everyone throws around, and it's hard to imagine that this would be a literal term, but is the lights out factory.
Right.
And I would assume automating the component storage and parts storage in general is one step closer to that lights out factory that we all, I don't know if we dream about it in a good way or nightmare way, but it is hard to imagine a true lights out factory. But again, I think it's more of a goal. I don't think maybe we'll be there, at least in our lifetimes, but every step toward that is certainly a step toward efficiency and probably a step toward reliability, because it's usually us that are the weak link in terms of reliability. It's usually something human error caused.
Exactly.
Even if a machine does it wrong, it's usually someone who programmed the machine to do it wrong. It's not often the machine that fails. So
it did exactly what you told it to.
That's just like software. I used to write code for our equipment when I was 30 years ago. I wrote all the original code for our machines, and the old adage was the problem with software, it does everything you tell it to do, right? It doesn't
fail.
It doesn't make mistakes. It just does what you've told it to do under those circumstances, and that can be said for so many different things. Well, Mike Adamson, thank you so much for joining me today, and thanks for sharing your insight and wisdom and sage advice on storage systems, a topic much like the company I run, which is cleaning, that many people don't think about until they have a problem. So I share your pain in that, right? We're not the first on the list, on the dream team list of equipment people want to buy, but certainly your product is one essential key to that goal point of high efficiency and optimization that will lead to more competitiveness, that will really help, toward the shifting the balance of power when it comes to where manufacturing is based. And, I appreciate the work you do, and thanks for writing that paper. It was quite informative for me, and I am sure for my audience as well. So thank you very much, Mike. Happy New Year to you, and I wish you continued
Happy New
success.
Year to you as well. Yeah, this was a real pleasure. It had a lot of fun. Thank you.
Excellent. Well, take care, and we'll talk to you soon, Mike.
Thanks a lot.
Thanks for listening or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, such as Apple Podcasts, Google Podcasts, Spotify, and so many more. Also, be sure to check out my other podcasts, including the Concept to Creation podcast, where I feature conversations with entrepreneurs within the electronic assembly space, and the Innovations in Technology podcast, where we discuss innovative products within our industry. All three shows are also available in video format. Check out the Reliability Matters or Concept to Creation or Innovations in Technology podcasts on YouTube. Just search the show's name and you can find all three shows. Or go to MikeKonrad.com. That's Konrad with a K. All three shows also appear there. Again, thanks for being part of my podcast family. I appreciate you being here. Until next time, stay safe, stay healthy, and stay happy. And of course, keep doing it right. See you again soon.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.